Great team. Thank you so much for everybody who joined already. I think people are still joining, but let's continue with our thing. So just to discuss with this, right? I know you guys are all, this is a webinar on the Docker. Uh, our practice is that, we always start with the behind what's goes on scene, and then we go into the depth again. So, but before that, let's get introduction part. Okay. We are DevLabs Alliance people, so we are actually giving a lot of courses apart from these things also. But yes, this is a quick slide that shows about our company, and then we do provide a lot of other courses as well, like you can see it on my screen. This is one of the things which we are starting, and then we hope we'll be doing this one also in the future for all the programs along with that what we are doing right now. So this is a quick thing about the company and then what we do. We are just to come to the introduction part about myself. I'm Naresh. I've been in the industry or IT industry for a long time now, close to 15 years or more than 15 years. And then we've been in the training also for last more than 10 years. I can say it. We've been trained so many people on the DevOps side. I know they recently started with the DevOps, but we did already trained a lot of people on the DevOps plus Docker as well. The Docker is one of the emerging technology that's going in the market, right? So that's what we've been doing it for the long time now. And apart from that, okay, we do corporate trainings as well, and then all the stuff that we can do it. We are proficient in training. Actually, our passion is to train train the people to succeed in their lives. So that's what we do it mostly. We try to give our best every time. So please try to cooperate with us, and then for the next 1.5 hours, I hope you will get the best out of what we can do it. This is mostly the a theoretical part, or overview of like how you get into the topics and the Docker. Basically, that's what we do it mostly. And we do show some kind of a practical also at the end. And also for all of your questions or anybody having any questions, we will open the slot in the between. Just to give you information here, so we will open the question slot in between some time, so you can ask your questions. If you have the questions still, meanwhile, you can post it in the questions panel or the chat window actually. So we will try to answer all of your questions, definitely. That's what we are trying to do it. And this is where the team, this is what it is about. We are in the session right now, so I hope you guys are ready for it. I know you guys must have come with that with a lot of expectation here with what is Docker and then how Docker works and all that stuff. So let's get into the topic, right? And then we'll try to understand what exactly is Docker. But before that, as I said, like we never start with basic directly jumping into the topic, right? We do always give a small background how it works, why we have to move towards the Docker, or why we have to move towards any of the technology that we teach it basically. So today we are doing Docker. Obviously, we always again, right? We will go with a little bit background there, what exactly was there in the market, and then why the people are moving towards Docker, as well as why we have to move to the Docker. That's what is the question basically. Everybody might have it. And I can say that, presently in the market or the Docker is like kind of, emerging very fast. And then, in the future or in the near future, you might see that every company that is adopting the Docker basically, why is that? Why exactly everybody is doing that? So we will try to understand that part definitely in the next 1.5 hours. So let's get started with that. I know about, there are a lot of people joined the sessions already here. I believe everybody is from a mixed background, maybe here, right? Maybe some of you are developers, or some of you are maybe, operations people, or some of you are maybe in the maintenance teams or whatever it can be in the organizations, right? So considering that part, right? Like we have mixed bag of people here. So in order to bring everybody on the same page, so we will start with the behind again. We will go a little slow, and then wherever you have questions, please feel free to put your question in the chat window. In meanwhile, in between, I'll open the line for your questions. Also, we can talk, and then we can answer your questions also at that time. When I open the line, you can ask your questions on the line, then you can definitely get your answers, all of them. Okay. So this is what is about a quick introduction about ourselves, like what we do, and then all this, all the things, right? So, and then this is where, team, we are coming into our topic now. Jumping into our topic, right? So this topic is all about Docker that we are doing it. This is just a quick introduction to Docker, how it works and all that stuff. So why you have to learn the Docker, or why exactly the Docker is in the market right now, how it is going to change the future of, IT industry, or, IT, that present technologies, why they have to shift towards the Docker. So all these things we'll come to know in the next 1.5 hours for sure. So before that, right, let's get started with the behind, or let's get started with the basic understanding about IT industry, or whatever it can be, right? So here, when we talk about the IT industry, basically, so we always do, our every IT company does something. So the outcome of your IT industry is always something kind of, you produce an application or a software, right? So where we do host these applications, what are these applications basically? You need to understand a little bit background about these things. As you can see it on my screen, right? There is some simple thing. At the end of the day, you might have a software or an application, right? So what sort of applications we have it in the market right now, and then what is the different types of applications, and then how do we host them, right? How do we access those services or anything that you do it? So if you quickly jump into any sort of an application, right? Uh, I know everybody access so many applications nowadays. Everybody does a lot of, mobile gaming and then mobile applications. Everybody use a lot of applications, but how exactly they serve, where exactly they will come from, right? So as we speak it, as we talking, right? So every company or every IT organization, they normally produce some software and then they do it. So whenever you develop an application, basically, how do we make that as a service, right? That is what is the question. So here comes, right? So when it comes to the application side, we normally have like little bit background again, right? So when the developer writes the code, we normally take the code and then we build the code, right? We build the code, and then building the code here means basically you are actually producing some kind of deployable artifact, maybe. I mean, I'm talking the terminology, technology here, guys. Try to understand that. So a deployable artifact, in a layman language, we can call that some kind of executable file that we created normally, right? So just an example of, if you want to take, or if you want to install an application on your Windows, like a VLC application, maybe you download something called as executable file, like .exe file, and then you normally double click on it. Like there's a lot of code behind that one executable. When you run that one, basically it installs a program on your thing, and then you will be able to use that particular application, right? So this is what it is. So developer writes the code, and then we build the code. We build the code to produce an deployable artifact, or we call it as some executable file you created, so that can be deployed in your systems, right? That can be deployed somewhere. So where we actually deploy these application again, or whatever these things. So when it comes to the types of application, so if I ask you a question like, maybe what type of applications you guys know basically, can somebody quickly answer me in the window, like what is the different types of applications that you have it in the market, or whatever that you come across so far? So what is the different types of applications that you see normally? Team, everybody, you guys are able to hear me, right? So I'm asking something, you can respond in the chat, guys. I mean, types of applications. Okay, great. Somebody says web, batch, mobile, web. Okay, web and mobile. Okay, okay. Embedded. Oh my God. Okay, desktop. Yeah, that's one answer. Got it. Web and desktop. Okay, mobile. Great. Cloud. Team, I'm talking about the applications basically here, not about infrastructure or basic thing. I know web and mobile applications are all applications, but let's try to understand this, right? A simple thing. Let me open my paint, and then we can start digging it. So you guys able to see my paint screen, or the previous screen by itself? Okay, Jenkins, no. Okay, let me share, right? Okay, let me share my screen. Okay, so here we go, right? So when I'm talking about the application team, basically, normally everybody works in organizations. Right? I hope everybody is able to see my screen now. Right? Okay, so what I'm trying to say here, team, is basically we normally get a different type of applications, right? Something called as desktop applications, right? And some called as web applications, and then something called as enterprise applications, right? So this is different types of applications that we call it normally as applications. Means everything like, the Jenkins, whatever you're calling it as, cloud. There are different applications, but they fall under these categories. I'm not asking you about the applications, but applications are what kind of applications that we normally do it. So just to tell why we are discussing this again, desktop applications are a kind of application you normally install on your laptops or desktops. Basically, the disadvantage with this application type of applications is normally like, you at a time only one person can access it, right? Everybody agree with this. So we normally access this application, whoever is in front of the system, those people only can access these applications basically. So that is what is kind of a desktop application, we call it. And when it comes to the web application, right? So what do you mean by web application that you guys get it? That's what is the question here. So when we say web application team, so what do you understand by web application? So why do we go for the web applications normally? And can somebody quickly tell me what kind of web applications you have it in your organizations or kind of stuff? So, okay, great. So Zabbix, Flipkart, okay. Flipkart is a web application, we call it, or maybe not. Yeah, it's kind of web application only, but there is a small difference between your web application and enterprise application. That's what I'm trying to get it. Yes, Jatin, exactly. So team, when we say web applications, right, the web applications are a simple web content applications. Those you can access through the browsers, basically through the internet or through the network. You normally access them through the network, right? So whenever you have a web application, the web application content would be same as you see it. Like if you go for, devlaballiance.com. So whatever the content that you see it, though, no matter what, who access that page. So basically everybody sees the same content, or it is kind of a static content, we can call it, right? It is kind of a static content that we call it. So whatever it can be, right? It can be images or any kind of information that you're looking for. Everything, you see it as a static content. You traverse through the pages, but the content would be same. There is no special thing required to read that content. Everybody on the online can read the same content, and everybody can do the same thing on that. So that is a kind of a web applications, we call it normally. So in order to host these web applications, right? So in order to host these web applications, normally we need some kind of servers, right? Everybody team agree with this. So in order to host our applications, in order to host a web applications, we need kind of a server, or a server is something. It works on a request takes a paradigm, right? Service and request basically. So that is what it does it. So we need a server. Can somebody name that, kind of a servers that is required to host your web applications? Does anybody know a kind of server that? Yes, of course. Himanshu, perfect. Anybody else? Yeah, Himanshu says it's IIS, a kind of, yeah, WebLogic. Not AWS, I call it Windows Linux server. No, guys, don't confuse with this. Yeah, Nginx, Hettinger, JBoss. Okay, fantastic. See. So team, let me tell you clearly, right? So in order to host our web applications, we normally use web servers, right? So web servers, we call it. Under the web servers, we have different types of web servers. I hope you people already know this. Maybe, putting this in this format, maybe you're confusing here. Apache or Nginx or HTTPD, right? These are the different web servers which will help us host our application, host our web applications basically, right? So we need kind of a server where we can host that, so that that becomes a service. And service you normally access through the network, so that everybody can see it, or multiple people can see that the response from that server, and then they can access the application and read about the content, whatever it may be on the web application. So that's what is about your web applications basically. Now the question here is, what is enterprise application then, right? What is an enterprise application here? So anybody can answer. So team, anybody? So what is a enterprise application here? What exactly is the difference that you think about, web application and enterprise application here? So when it comes to that, I don't see any answers here. So team, that's fine. So large level, yes, of course. So when we say enterprise applications team here, basically, enterprise applications includes some business logic. Yes, exactly, Anirudh, you're absolutely correct. Facebook or Amazon or Flipkart, they have some kind of a business logic inside it so that they process some business values, right? Kind of, just take an example of, if you take Amazon, the first thing which comes is a login page. You need to log in. So there is some kind of, authentication happens basically. And whenever you log in into the application, then you see your own content, like your own account settings and everything. Likewise, the application is seen, but based on their accounts, normally they show a different content here, right? So kind of everybody has their own pages developed for them, and it kind of shows a different content for every user that gets logged into their applications. That is nothing but enterprise level applications where they host it a different kind of logic for every user they log in or every user they create it. And they also some kind of have business logic in it to communicate with other services like banking systems. Like if you take an example of whenever you go to Amazon and then you add to cart, then whenever you click on the purchase options, right, then it will connect to your banking website, right? It is kind of integration with other websites or other services where you want to communicate. So this is kind of, a business logic that is built around your application, then that is called as an enterprise application, right? So these kind of applications are developed, and they are, the examples as I told already, like, it's kind of Amazon, or it can be Flipkart, or it can be FB, whatever it can be, right? They have some rich business logic in it so that they can process more than what the normal web applications do it. Web applications are just shows the content for every user, same thing, right? So that's what it is basically. So this is how it is. Now, to host these enterprise applications, now, what kind of services that we needed, right? What kind of a way do we host these web enterprise applications? So what kind of a server we need to host these web enterprise level applications now is the question, right? So what do you guys think? Now, what could be the server? Can we host our enterprise application on web servers? Yes. Okay. Data centers is huge, Anirudh, to say that, I am asking about a particular server where I can host my application, basically. Just host the application, right? I know, data centers host the number of servers, hardware, and everything will be there. Yes, exactly. Okay, that's app servers. Yes, so that's something called as, we call it as app servers, basically, or application servers. Nginx can be used. Nginx is mostly content of web server, Anirudh, not exactly the enterprise level applications can be hosted on your Nginx. Nginx can act as your router, routing based mechanisms and all that stuff. Okay, so when I say app servers, right, what are the different, yes, we have WebLogic or WebSphere, we have different kind of Tomcat or, kind of JBoss. These are all, different kind of application servers that host your enterprise level applications. And so this is kind of, just a background team. I know everybody works day to day on these things, but they really never think about these things. So we're just giving a background here so that we know everybody gets a clear picture of what we're going to do with it. So that's what it is. I know you guys know all these things, but just hold on sometimes so we can get into the real topic here. That's of course. So this is, the quick background about, what exactly is an application, what exactly is a server, and then why do we use these different server. And at the end of the day, we need a servers to host an application so that becomes a service, right? And then we can use it as a service over the network. And then, we do all of our operations or day-to-day our activities, whatever it can be. So this is kind of a quick background where we are actually doing it, right? So let's get back into our PPT again. So yeah, this is what it is, right? That's what I kept a slide here for a server and application. So when application, then where we can host these applications are nothing but we call it as servers. So when we say servers team, and again, this is about, hosting your application, not really the Linux servers or Windows servers. We host our application servers and web servers and everything on top of a machine, which is nothing but your Windows machine or a Linux machine kind of stuff. So that's a different part again, right? So that's what it is. Of course. So this is a quick background about your application and thing. So now let's coming to the, again, let's going back a little bit background again. So I hope everybody might know this definition already, right? So just to talk about this thing, what is software engineering? Yeah. So this is what is the end goal, right, of any IT organization again here. So the software engineering, we are in a software field, so we do software engineering, and then we do produce the softwares. So how do we do this process is the matter here. So if you can read about the definition here, the application of systematic, disciplined, quantifiable approach towards the development, operations, and maintenance of a software. So this is what is called as, software engineering. Again, why we are talking about the software engineering, if you can, concentrate on the words here called as development, operation, and maintenance, right? This is what is the main goal of any organization they do normally, right? They normally develop an applications. Once the development is over, it's not the game over, right? We normally deploy that application into multiple environment. We operate that software, we test it, we ensure that it is working as per the requirement. That's nothing but we call it as operations. We do a lot of operations inside and then ensure that your software is working as expected. Once that is done, we normally put into the production where that can be accessed by your end clients or end users, and they will enjoy the features of your applications, whatever you do it. So this is what it is, quick, and of course, once we do deployment, and then if the end user is accessing their application, end user is enjoying the features, but we also want to maintain the application. Why? Because again, we have to maintain this application, ensure the uptime, or ensure that your end user is always feeling the same, or end user experience is always the same, right? So we normally kind of maintain this application, whatever it is you deploy into the production, and then you ensure that the application is up and available all the time, so that every every bit of your application that end user is enjoying always, they are not facing, or you can take the feedbacks. If there is an issue, of course, again, we will come to know from the maintenance, and people will do report the issues. We can go back to development again. This cycle continues. It's repetitive. It's repetitive, right? It's continuous, going on always. So this is the life cycle of your software engineering, basically, that we do it in every organization. So this is what it is. Again, just to give a quick background about applications, servers, and the software engineering, what exactly we do and things. So this is what it is, a background of things. But okay, so in order to follow this process again, software engineering, I know we started this software development again, way back in 90s or somewhere, when we started with the computers and all the things, right? So how exactly this software engineering is evolved? So how exactly we used to develop, how exactly we used to maintain or operate softwares, what we created, everything. So there is kind of evolution that happened from the inception of your, from the inception of your software engineering, or from the inception of your computers, or what happened exactly in the behind. So let's jump into the evolution of IT now, or evolution of your softwares, how exactly we used to develop and all these things. So let's jump into, quick background again, how we evolved ourselves in developing these softwares and then maintaining or operating these softwares over the years, so that, so that we'll understand more better, and then why we exactly moving towards the future, how exactly the latest technologies that we're going to use it in nowadays, which is one of the things is Docker, of course, how exactly this will help us, make more knowledgeable, more thing on our more strength on our resumes, or whatever you call it. Okay, so that is what it is we are trying to understand. So let's look at the evolution of IT that we are trying to do it. What exactly was there in the before, like when we started with the IT industries way back in 90s or somewhere, when we introduced our computers and all. So how exactly we used to do it. So that is what it is, team. If you can look at my screen now, I hope people might have come across this or not. I'm not really sure. But those who are having experience of ample experience, or over 25 years of experience, they can feel that, okay, this was the one they used to follow in those areas, or in those days, basically, right? So the development process, right? The way you develop the code, basically. So we normally used to follow some method or some process called as waterfall method. So what exactly this waterfall method is about? And then, about the application architecture should be about monolithic architecture, right? What exactly this monolithic architecture? And then, this is about the development process. Now, after this one, like once your development is over, of course, we always deploy the application or deploy the software into some kind of a server where we can add that as a service, right? Where we can use that as a service. So that's where on the operation side, again, physical servers, where exactly we used to host our applications and all that stuff we need to take it. So when it comes to the waterfall method, I'm not sure how many of you know about the waterfall method team. Can somebody quickly tell me, do you know it or not? How many of you know this waterfall method? I know you might have read about in this in your engineering or in your studies, but just to give a quick recap of this one, what exactly is the waterfall method? Can somebody quickly tell me? Do you know anything? Yes or no? Maybe the answer. It can be anything, Tim. The answer can be yes, no. That should be fine. But yeah, let me know if you know about this waterfall method or anybody. Guys, please do respond in your chat soon. Okay. Yes, people say yes. Some people say yes. No repetitions one. Okay. Yes. Okay. People do say yes. Okay. Great. If you're all aware of it already, yes, that's really fantastic, team. But let me quickly tell that what exactly used to happen in the waterfall method, right? The waterfall method is nothing but, your step-by-step process, we can call it. When I say step-by-step process, I'm using a very layman language, team. So just to make sure everybody understand this one, it's a step-by-step process. That means that whenever the requirement comes to you, basically, we normally follow something like, one after the other. Means that again, you normally go for a requirement collection first. Once the entire requirement is taken, then you go to the design team. They will design something. Then you go for the implementation, like standard process, right? Develop a software, basically. Requirement gathering, design, implement, and then test it. Then, deliver the code, deliver the software. So this is what used to happen in the waterfall method in a step-by-step process. That means that until we collect the requirement, we never go with the design phase. Means that, the design, implementation, everybody sits idle until you get the requirement from the client. Similarly, every phase, right, it goes one after the other. So that way, right, you are actually taking a lot of time in developing your software. Means that if the client gives the requirement today, you might be delivering that software after a year. By the time you deliver your software, client may change his requirement again. Maybe, it's kind of repetitive again, everybody does not love it. You need to deliver the software faster. So the waterfall model never used to do that one. So it has to be done by step always. Then at the end of the day, once you deliver it, the client will change his requirement, client will not be happy, all that things. So that's what used to happen basically, but they used to live with it because that is the only thing they used to, they wanted something. So they used to do that one. So that's fine. So that's how the waterfall model used to take a lot of time. I know we are in the world where we are moving very fast nowadays. So that model never works out in the present world, but we moved or we evolved as we spoke, right? This is the first era of your evolution of IT. So that's what is a basic thing. And when it comes to the application architecture, right? That's the process they followed. But when it comes to the application architecture, we call it as a monolithic architecture. Why we call it as a monolithic architecture here? Basically, right? So when we develop an application, there are n number of components that involves with this particular application or any application, right? Just take an example of, your just now we discussed about some kind of a web content or, enterprise level applications. Your application may be talking to a database server. So everything is, tightly coupled together here. Your application is not a single line of things. Everything is tightly coupled so that, whenever there is an issue with it, basically entire system has to go down. And then, that architecture was typical to understand or typical to debug, typical to resolve an issue. And then one thing goes wrong, everything goes down. So that kind of architecture we used to follow. And then, that worked for some time, but, that was a very big drawback. So people dropped from it, of course. That is kind of, a monolithic architecture, we call it. So that's one thing. And of course, okay, you successfully, done. You followed waterfall method and you followed monolithic architecture, but you successfully developed your software. But where do we host the software again, right? Where do we host this? when I say hosting the software, when it comes to the operations part, earlier days, we used to have something called as a big servers, physical servers, we used to call them. When we say physical servers, right, again, it's kind of a big hardware where it has a lot of resources, right? And then you normally host your application on top of it. And then once you host a single application on top of one server, and then, it is hard for us to, put another application there basically. So it is a lot of resource wastage that used to occur on the physical side. So people did it, but later we moved on. But yeah, this is what used to happen in the first phase of your thing. And where we used to host all these servers again is some kind of a data center. I know people do know about the data center now. So data centers are kind of a building or a place where you host all of your hardware and then servers, keep it and then connect to it and then you do it. So this is, this is what we used to do in the first era of your IT evolution team. So I'll stop here maybe. For 1 minute and okay. So, I mean, if you still have something doubts here, you can put your question. As I said, like, I don't see any questions, team. I know I'm speaking here, but if you have any questions while I'm speaking also, you can put your questions in the, chat window. We will try to answer there also. Okay. But try to go ahead. So this is what it is about, first era of your evolution, IT evolution, and then coming to the second phase of your IT evolution, right? Where we changed our process from development process, right? From waterfall to agile. So I know everybody is working in agile right now. I hope everybody, right? Is anybody not working in agile here? Team, I hope everybody know about the agile process. Guys, yes. Okay. Scrum, fantastic team. So yes, nowadays I know everybody is working in the agile process. So what exactly agile says for us, right? So agile says in a simple rule, a divide and rule policy, right? You normally split, you normally take the requirement and you split the requirement into multiple modules or multiple components, and then you assign the work to each of the things. Person, and then you normally work in parallel here rather than working in a serial way, right? Not one after the other step basically, but you work here in parallel completely, right? So you take the requirement and then you normally break down everything into some kind of user stories, we call it in an agile world. So every requirement is split into a user story, and then the dependence, the technician, whoever is working on that particular area, so means developer can take the development user story or kind of, right? Everybody takes their user stories, and then here, right, you have kind of a sprint, we call it in the agile. We normally have a sprint so that you take the work and then you have to report it back in a couple of weeks, or that's what is a process that normally goes on here. So the agile is a process which helps you develop your software in a faster manner. That's what I can call it, right? Agile easily adopt the requirement and changes, of course. Yes, Himanshu. Yes, that's what, right? So in agile, you normally take the requirement and you go hand in hand with the testing or whatever it can be. You take a small piece, you develop it, you immediately test it, you immediately deliver it to the client. So this is how you normally speed up your development process entirely, right? Entire development process is speed up completely, so that you are earlier with a waterfall model, if you're developing your application in 1 year, now it has become, maybe in 1 month or 2 months, you will be developing your application completely, right? You take the requirement immediately and then you develop it and you give it back, you work with the client, and then, you normally come to know if there's an issue, then you redevelop it or retest it, everything you do it, and, iterative process here, we call it. Then entirely you do it, and then it goes in a parallel format. So everybody everybody loves this process also completely because we are able to develop it completely in a faster manner, right? That's what we're trying to do it. And that is what is agile, basically, simply we can call it. And when it comes to the application architecture side, we moved from monolithic to, NTR architecture, right? So what is NTR architecture here? When it comes to the NTR architecture team, earlier, as I said, like every component of your application, everything used to tightly couple together. But when it comes to the NTR architecture, we used to host our applications in different servers. Means we are splitting out our components separately, like web server component, or application server component, and a database component, right? And then different services, and then we normally host it in different servers. Then whenever it comes to the issue or some issue comes to it, we know that particular component has issue, and then it helps us it helps us, troubleshooting your issues quickly, and then later on you normally develop it properly, right? That is what is nothing but your NTR architecture. Normally, rather you host your application in a single server, we normally host it in multiple servers. That way, you are normally ensuring your uptime of your application also very high, right? That's what is basically comes to the NTR application, NTR architecture side. So that's what it is. And once after this one, with this architecture and with this agile process, of course, we're able to develop our, software very fast, and we are ready to deliver it. Of course, whenever we want to deliver it again, we need to go to the operation side, of course, again, where we host this application again is a question. So when it comes to the application side, operation side, basically, so we converted, our physical servers into virtual servers. When we say virtual servers again, what do you mean by virtual server? Yeah, we split our physical servers into multiple virtual servers here, right? When we say like, it is like, segregating your resources and making small servers on top of your same hardware. Like there is some kind of a technology like hypervisor or VMware or Citrix. They allow you to virtualize your hardware so that, you create multiple servers on top of the same hardware. And then on top of this one, basically every server has its own operating system now, and then every server has its own operating system plus whatever the stack that you want it. Maybe you can host a web server or you can host an application server on top of it, you can run it. So simply we can say that, a same hardware is split into multiple servers here. And so that, the efficiency of your resource utilization and everything becomes much easier now. Like the efficiency becomes more, right? So that's where, you're able to produce or make use of your hardware very effectively. So that's what is nothing but, your virtual servers came into the picture. And with the virtualization, I know everybody using the virtual servers nowadays. Even the cloud is a virtual team, but just try to understand that this virtual is like on-prem, you have some kind of virtual servers. The same hardware has been split into multiple servers, where you get a lot of advantages with resource utilization and everything. Okay, so that is what is a virtual servers basically. And when it comes to the application infrastructure side, right, where we used to host these servers again is a question. Earlier we used to host in the data centers, of course, right? When we say data centers, again, your organization has to have a place where they can buy the hardware, keep the hardware and everything to it. But when it comes to the hosted data centers, what it means is basically, rather you create your own servers. Normally we go to any other organization, we get the servers on rent. Simply, I can say that, it's like you get a server on a rent and then pay for whatever you use it. At the end of the day, they will set up the servers, they will maintain the infrastructure and everything. And basically you just use the server and you host your application there. That's what all we used to do it. That's nothing but your, your hosted data center, we used to call it. Means here kind of, you don't need to really buy anything, but you can rent it and then you can use it as you go. And then you can, whenever you want to not using them, you can give it back. So that's what it is happening. That's what happened in the second stage of your IT evolution, basically. So this is nothing but your application infrastructure where we hosted now. Now, after Agile, yes, this Agile process is working very fantastic. We are able to deliver the software faster. But the next stage, right, that's what we are in the current world right now, right? That the next stage is where because we are using it completely, this is what it is, right? We are in a world where we are actually using now, everybody says something kind of a DevOps. What is DevOps again? We need to know development. A lot of people do say that it's kind of a development plus operations and blah, blah, blah stuff, whatever it can be, right? So what exactly is DevOps? I know we kind of do the DevOps courses also, but try to understand here, we are in a world where we are using the DevOps. Simple definition of DevOps, I can say, is where, we bring in the, Agile process into the operations also. Earlier team tried to understand Agile process was brought in only in the development area where they were able to develop the software faster. But when after your development of software also, if you host the application, we need to get help of operations team. And then basically once you reach out to them, they will normally post your questions like what kind of servers you need, how many servers you need, how many users you normally require. All those questions comes up. And to host your application, it may take another 6 months, right? Another 3 months, I would call it. So altogether, again, you're reaching out to around 6 months to deliver your applications to the end user. So that's what is a problem with the agile process. I can't say that it's a process thing, but agile was not introduced in the operation side. So we were not able to deliver our software fast enough to your end user. So that's where the DevOps came into the picture. Development plus operations, people do say that again. Yes, of course. It is like, earlier development team doesn't know the operations team and operation team doesn't know the development teams. But with the DevOps, basically, people do say that development teams and then operations teams should together sit together and make a good collaboration. Then you work towards a single goal. That's what is called as, you work, everybody works towards a single goal, and then you deliver your software fast enough. That's what is nothing but DevOps teaches, but that's not what we're discussing here, but try to understand. So DevOps is a process that helps you deliver your application faster. Again, of course, that's a process we changed through. And then, when it comes to the application architecture side, we changed from n-tier to microservices. The microservices is, again, we divide our application into bits and pieces more. Like every service, every module of your application can be run as a service separately, so that, simply I can call that as, when you have a login page can be run in a different process. Like login page can be developed in a JS script, or when it goes to credit card module can be used hosted in a web server or application server somewhere. So different services, you see it in the behind, but in the front end they will act as a single application, right? So that's what it is. The microservices, it's kind of you're splitting your application into more of bits and pieces, smaller services, so that the development becomes faster. Again, the service deployment becomes very faster, and all those advantages comes with your microservices. There are a number of other advantages also, but these are the main things that we can call it. Now, this is our very important point, right? Where we are trying to do it. On the infrastructure side, we converted to microservices. Okay. On the infrastructure side, we are moving from virtual servers to the containers. So what exactly is this containers basically? Why do we need containerization, containers? So is virtual server is equals to, is virtual server is same as container? So people do have a lot of these questions basically. So that's what we're going to do it. So the containers, that's what we're going to discuss, team, in the next slides, of course, but I'm just stopping here again. We're going to discuss more about the containers. That's what is our course, of course, about this one. So this is what it is. We switched from, virtual servers to containers. That's what is the underlying thing here, but we'll discuss more of the containers in the next slides. So on the development and packaging side, that one, but on the infrastructure side, I know everybody's moving to the cloud nowadays. So I hope you guys know already what is the advantages with the cloud, right? Everybody. So whenever we go to the cloud, it is like on demand, pay for what you use it. Earlier, if you want a server, you need to go to the X organization, you request them, they create the servers. They take the normal same process, and they take the same time as you normally take it, so that but they will be on their data center. That's the only difference with your own data center and the hosted data center. But with the cloud thing, right, you get it whatever you want it on demand, and then whenever you want to use it. You have the control in your hand now, so that you can get your servers, everything on demand whenever you want it, and then you can also pay for what you use it basically, right? That's what is the advantage, biggest advantage with your cloud. So if you want to use it for only 6 months and use it, and after that you can give it back, and then they don't charge you anything, and then you can simply avoid that whatever you have. So that is what it is, team, the cloud. But this is about IT evolution basically. That's where we evolved from older days to the nowadays. Nowadays, yes, we are using the microservices and containers. So this course is about, of course, Docker. I know before we started, we had a good background, like why we are moving towards this Docker or containers, basically. Let's try to understand the containers here, right? So what exactly is a container means for us? And then why exactly we need to go for this containerization of our applications. But before that one, again, let's try to discuss about the containers, how they help it. And then, just things, right? So I'll stop here for some time. If you have any questions, we can open the line, then you can ask your questions, team. I know I don't see any questions in the chat here basically. So if you have any questions, we can quickly discuss about the questions, and then we can jump onto the containers. We'll discuss about the containers. Can I open the line now so everybody can do it? So I'm unmuting him so you can. Everybody. Okay, sorry team, I have unmuted all of you again. So if somebody wants, you can unmute yourself if you have any questions, and then you can talk on. That's what I can tell you, but it's rather, that's good way. You can unmute yourself and then you can ask any questions if you have so far, whatever the discussion that we had it. Everybody, any questions?
Yeah, Naresh, I have one question. Like, as you said that regarding the microservices, so I just wanted to know, like, see, microservices are like the services we created, but they are specific to some domain, right? So, how do we host these microservices, and how a single interface will be there for all the other microservices? Like, are we hosted each microservices separately, or we have a single something like we can host all the microservices in one go?
See, when we say microservices, right? So microservices are hosted different. Okay, every microservice is hosted in a different technology or different way only. But at the end of the day, right, you will see as a single UI or single interface. That's what I'm telling you. Why? Because again, these services internally talks to each other and then they make as a single application for you. How they talk is something that you need to find out, like using REST API calls or whatever it may be, right? We are splitting out the functionality so that it makes our life easier to deployment. Or nowadays everybody expects even no downtime applications. Just take an example of, if you can see the PowerPoint itself, right? Just an example I'm taking it here. If I have an issue with kind of this chart button in my whole application, right? If I want to fix this issue in this particular chat thing, I might have to take down my complete application down. Yes or no? That's what happens.
Yeah.
I have hosted my entire application as a single thing in a background so that you have to take down an entire application to do this. But if I host this particular service and this different service, like every point of this one, right? Every feature of this application is hosted as a different service. Now you tell me, if I have issue with the chart, right? And then I can take down only the chart service and then I redeploy it or fix it and redeploy it. But meanwhile, my entire other application is still works, right? So the end user can still use it. So that is the biggest advantage. But how they communicate with internally and then how they act as a single interface in the front, that's all dependent, like how do you develop the microservices and then how do you ensure that they communicate with each other, right? That's what is the logic that you need to build on your development side. So they will do it. Actually, people are doing that in that way, so that that helps us maintaining your no downtime applications or 24/7 applications that we call it. So that's what it is. I hope that answers your question.
Yeah. That sounds good. I have one more question I have. Like, for all these microservices, we have a single authentication authorization, or we need to apply the in each microservices?
See, that again, right? It depends. Like if you're talking to a particular microservice, if that microservice requires some authentication or something, then you can internally call it. But whole as an application, right? From the front end, if you see a login module, that's the single authentication that you do it. So if every microservice you're interacting with requires authentication again, you can inbuild an authentication internally with a microservice, or you can use a single sign-on method. Nowadays, everybody uses a single sign-on thing. So whatever the credentials that you use it as part of your login, those can be internally used for every microservice authentication also. That's again the logic how you build it. Of course, that depends on your application architecture, how they build and everything. That's how it does.
All right.
Both options.
Thanks.
Both
Okay.
options.
Okay. Thank you, Naresh.
Sure. So anybody else have any other questions, team? Everybody, I hope I know this is all about the background. Still we discussed, we are already 1 hour, we started the session, everything we discussed about the background. I know this is what is needed. This is, very basic. If you understood this part, then the containers are easy for you to understand now. That's what I can call it, right? That's what I can give you confirmation, whatever the things which we're going to discuss now. So that will help you all the, you can correlate all these things. We can do it. So team, if you don't have any questions now, so I'll proceed with the next thing, right? And then we can start discussing about the containers. And I'll open the, we can have the questions again at the end of the session once we have done. right? So is everybody okay with that? Okay, I assume people do say yes in the chat. Okay, great. Okay, so team, great. So let's jump onto the containers, right? So what do you understand by containerization or container here, right? So let's try to discuss about the general containers first, how they helped, resolving a lot of problems in day-to-day shipping mechanisms, I can call it. Why I'm talking about this again is like, if you understood this part, the next thing is like, what we are talking about is software containerization, right? So what exactly is a container? Why exactly we need to build this container, so that what exactly the problems that are there in present environments, present scenarios, that will eliminate all those problems with this containerization. What exactly the containerization helps you with. So these are all the questions that you get answered maybe with these questions, right? So let's try to find out the answers for all these questions that we have it in our mind right now. So discussing about the general container here, as you see it on my screen, right? This is general container where we normally use for what? We normally use these containers to ship the goods from one location to other location, right? Everybody agree with this? Yes, team? Everybody please do respond so that it helps me to move forward quickly. So okay, great. So what can be moved, right? Again, before these containers, before the general containers itself in the market right now, so how exactly we used to ship the goods, and what are all the different problems that we used to get it, right? So if you can take an example of, you want to ship your home from one location to other location, whatever the goods, materials that you have it in your home, maybe some kind of or kind of like oil barrels, or piano, or a car, whatever it can be, right? What are the different types of goods you have it? How do you ship them basically, right? Because some of them are fragile, some of them you can take it as you go, whatever it can be, that this kind of things you have it. So how exactly we want to ship these things without a container? So if you talk about it, there are a number of shipping mechanisms that we are available, again, like shipping through your trains, or shipping through your road transport, or any other things that you want to do it. So this is how there are. Now if you go and ask you like, which one has to go with this kind of a mechanism, with kind of a transport you want to use it, because maybe, right, to transport your car, that the train may be the best option you have it, right? That's kind of a things you normally think about. At the end of the day, there's a lot of complexity involved in shipping these goods from one location to other location. But there are a number of other chances also, like if you ship your piano from the road transport, and then in between there is a chance like that can be theft also, right? Because a single piano and then somebody wants to do it, yes, they can go for do it. So there's kind of challenges also that comes in the picture when you ship it different goods with a different kind of a mechanism, different kind of a transport. There's like there's not altogether it's easy for theft, easy for thefting the things also. So that's what is happens with this one before the containers, right? Now when you think about a container, now let's put all these things into a single container. Like you have a big container basically, and in which you putting all the things of your own, and then you tightly locked it up. And then at the end of the day, for the transport guys or whatever it can be a single unit, now a single container that they have to ship it. Now you can simply opt for any of the mechanism, any of the transport type that you want to ship it towards this one, right? So it makes your life easier. And then whenever you put everything inside the container, that is, that provides you a lot of safety for the fragile things also, like, because outside material is very hard, and somebody, if they want to theft it also, that's not so easy to theft things from this. And at the end of the day, you will get security and all that stuff with this containerization, right? So this is what is happened whenever you ship everything inside the container. And it also eliminates a lot of cost problems for you, right? Because you don't need to worry, you can pay one vendor now, like a simple vendor, like whatever it can be based on the weight or what it can be. So this brings in a lot of advantages when you put everything into a single container and then you ship it across one location to other location, right? So that's what it is basically. So that's what is the biggest advantage that you get it with the containerization of general shipping goods now. Now, let's think about software containers, right? Right? That's what is the thing we are talking about, right? All the time. So what is software container? What can be containerized in a software things, right? So what do you guys think about software containers team? So what exactly we can containerize inside your software, right? Everybody? team, what exactly we can containerize? So just an example team here again. Okay, just a quick thing. I'll go here. Application and associated services. Yes, of course. Don't worry about this other side. Okay. So what I'm trying to do, team, here, I'm dividing into two sections. My thing here, basically. Okay. Here we have without containers. How we used to do it, right? Without containers. Okay. And with containers, what will be the advantage that you get? Okay. So with containers, that's what it is basically. So team, that try to understand, right? Whenever we build our application, we build our code, we normally produce something called as executable unit. Kind of when I take a Java application, normally you get a kind of WAR file or jar file. Everybody agree with this, right? We normally have this kind of a file, and you want to deploy this into a different environment. Like, you might have some kind of different environments in your organization, right? Maybe like QA, right? QA, pre-prod and prod, everything you have, right? So you don't directly deploy everything into the prod basically, right? So you normally deploy everything into the prod here, okay? And then how exactly you ship this application, right? So as I said, right, just take an example of ER here, then you want to ship it into your QA, then test it out, and then you ship it to the pre-production, and then you test it out, then you ship it to the production here. How exactly we need to we are shipping here is the question, right? We are shipping only the application file here, right? That is nothing but your only the code which is given to you by your developer. You build the code, you normally shipping your application into different environments. Now, in order to deploy this one, right, we need to have a server, of course, right? The server may be kind of a Linux server. On top of it, you normally have some Java installed, and on top of it, you normally have some server setup like, app server or a Tomcat, maybe we can call it. Then normally this is the setup that you have it in your every environment. Then you normally deploy your application here, right? That is what you actually do it. Everybody agree with this, right, team? So this is what you have it. You normally ship only your application here with this environment, with kind of a setup that you have it in every server, in every environment. So that's what we normally do it. But what exactly is the issue here? Shipping only your application file, right? That is what is the question. Now the question here is, I know everybody might have heard about this one. The application was working in the development environment. Now, whenever we ship this application into the production, the application is not working there, right? And immediately we open a call, we gather everybody, and then we bring in the developer at the last. And then what that guy sees, basically the first answer that comes out from there. Everybody know, I believe this one already, right? It is working fine in my development life, right? It is working in fine in my laptop. Yes, team, everybody say that, right? I hope you guys have heard about it already, I believe. So why exactly it was working in his environment? Why exactly it is not working in production environment or any other environment? It is not working. What exactly is the reason that's causing the issues here, right? If you think about it, like how is configuration data issue, of course, right? And apart from that, team, like if you think about the developer laptop, right? What exactly is the operating system that guy is using it? What is the Java version that guy is using it? And what is the application server or Tomcat server version that he is using it in his environment, right? He developed some, maybe using some kind of an open source or some kind of a free software that we developed, and everything he used it, of course. And when we go to the production servers, we normally have kind of enterprise softwares. Do you like normally, right? Licensed software that we use it, like IBM Java or something. Maybe in his laptop he might have used OpenJDK, but in the production servers, because we need a license and support everything, we normally use kind of enterprise software like Oracle Java or IBM Java that we used it. Then of course, right, there is a lot of difference between the thing here, what he used it, and then what exactly we have it in our production or any other environment. Now, that is what is the biggest issue, right? That is why there is a mismatch of all the concepts here, like all the topics here, basically. Like Linux, it can be Windows machine here, and then in production we normally use the Linux servers, and then Java version could be different, and the Tomcat version could be different in your servers. And this is what it is, right? At the end of the day, and then application related configurations also might be missing at your production server. That is what is the biggest issue, right? That's why we might be missing, because we are taking only the application code, but not anything else here, right? That is what is a problem. So we are just taking the application code and we are deploying it. Obviously it is missing, or there may be, a number of other certain situations where it is missing the configurations. So the application is not working in your other environments. That is what is the biggest issue that we have it now. So what is the solution for this basically, right? What is the solution that we have it for this particular thing, so that, it actually helps us, in resolving all these issues. So assume that now with a containerization, right? Because to host this my single application, I need a server, a kind of operating system, and Java, and then Tomcat, then along with that application information, and then your ER file, right? This is what is required. Now, can we package all this code together, right? So the same thing here, team. So here I'll have OS, and top of it I have a Java, and top of it I have Tomcat and the configurations, right? Configs. And along with this, now I install my EIR file, right? So this is what is the stack. If I can take it from the developer machine now, right? This is what is a package. If I can create or take a snapshot of your developer machine and then deploy into this environment, or deploy into this environment, or deploy into this environment, basically, then would you see that issues? Everybody, would you see that issues basically? No. Right. It's kind of taking a snapshot of your developer machine and then, shipping towards your, shipping into the different environments, right? Maybe QA and then pre-prod and then production. So everywhere you ship the same image. If the image was working in your developer machine, then that should have to work in your production also, right? That is kind of a thing that we have to create it. Okay. That is what is the solution. That's what probably the market looking at it basically. Okay. We'll take the whole image or dev machine or only required. So, okay. So that's kind of a question, Vinay. Again, that is what is the solution. That's what I'm saying, but it's not like entire development machine. We're not going to take the snapshot of it. There is a different ways of doing it. That's where the Docker comes into the picture. Okay. That's what is the Docker is for us. So Docker is our, solution here, which helps us creating this package for us. Okay. So we normally call this package as a Docker image. Okay, which consists of everything, of course, not your entire snapshot of your thing and whatever is required from your developer machine. We take everything and we package that together as a single package, which we call it as a Docker image. And then you take this image and then deploy it wherever you want. Deploying is something we call it as, create a container of. Whenever you run this image as that becomes a container. Means we are containerizing all the environment that is required to run your application, right? We are containerizing the things which is required to run your applications. We are putting all the configs, all the related configurations, all the related softwares, everything together to run your application. At the end of the day, we just have to run our application. So in order to run that one, we need a server and everything, of course. But here we are going to take a snapshot of your development machine so that, if it works in development environment, then it has to work in production also, right? That is what is basically doing it. So here is the picture comes into the picture, right? So here is what the Docker gives you the advantage of creating these images or creating or taking a snapshot of your development machine, whatever is required. Then you ship your image into different environments. Then you run it as a container. Right? So that is what is nothing but your Docker containerization team. Containerization, first of all. So Docker is a platform here that lets you create your packages or a Docker images or Docker containers basically. Okay. So simply telling team, Docker is a platform that allows you to create your images or packages or containers, we call it. So simply telling, Docker containers are nothing but your runtime environment that is required to run your application. Okay, so simply Docker allows you to create this one, and then Docker lets you create your images, a package, and then Docker lets you run this across the environments wherever you want it. So that is what is all about your Docker team. And then why? Because again, you see that whenever it comes to the containerization, containers are lightweight here. And then, once it is lightweight, of course, we ship it towards, and then we can run as many as containers we want it from a single image also. So that is the biggest advantage comes with your Docker here. Okay. So that's a thing about the team. So let's switch back to our PPT, right? So then we can look at it more. Okay. So as you can see it right now, of course, this is something, virtual machine versus containers. We're going to look at it now. Earlier days, right? So let's go to the Docker first, and then, so Docker is a, kind of enterprise level container platform. As I said, like Docker is a platform that lets you create your containers and then lets you run your containers. Basically, Docker gives the power of creating a container for your application. So whenever you use the Docker software, that allows you to create your containers, and then whenever you ship them towards any environment, right, you can run them safely without any, you know, without anything damage to your application environment. So whatever is, if the application is running in your development environment, then it has to run in your production environment also. So that is a simple thing about a Docker team. And then, what exactly the other advantages that comes with the Docker, right? So earlier days, if I want to scale up my application again, so I know it is hard for me to scale. Like if I have 10 servers and tomorrow I want 12 servers, in order to add 2 more servers, I might take, at least 2 to 3 days time. Now with containers, right, it's just a single command that will give you 2 more containers in a matter of minute. And then, you can scale up and scale down easily whenever you want it. So containers are very dynamic in nature. So they will allow you to scale up and scale down as needed and whenever you want it accordingly. So that's what it is going to be. Okay. And so, but this is simple thing, team. Again, Docker has started evolving from the last 2013. Basically, it came in the market, but nobody knows about it. Just a history about the Docker. So Docker is in the market actually from the 2016. It's 3 years from the Docker, evolved a lot in the market, and then everybody is looking at the Docker now to avoid a lot of problem that day-to-day occurs in a regular environments. Shipping your, deployment basically becomes easy with your containers and all that stuff. Okay, that's what it is going to do it. This is something again. So what exactly is the other advantages that comes with the Docker is something, as you see it already, like we can create a whole package here or a container, we call it, which is what we call it as a Docker image. And then we are shipping to every environment. So if it has to work in the development environment, then it has to work everywhere as same it is. Now that is the first advantages, of course. Second thing is like our containers are very lightweight. Whenever I say lightweight, like, it is as quick as, when if I ask you a question like, if you want to start your application, how much time that takes? And basically assuming that you install your application in your server, if I reboot my machine, how long time that it takes? So to initialize your application, basically, we might require at least 5 minutes, maybe, right? Because your server has to reboot it. And then your application server has to initialize. Then your application has to initialize. All these things takes a lot of time. And whenever something happens or restarting or starting the things, containers are very fast enough. A simple lightweight container can start up in 2 seconds also, right? So that is the biggest advantages with the containerization. Now you really need not to worry about the configurations that whether the application would run here or not. You don't need to really worry about it because containers are isolated from the host operating system always. And okay, so yeah, sure, Imanshu, you can go ahead. I'm sorry. Okay, sure. So yeah, that's what about it. Basically we are talking about this, right? The uptime of your containers, the startup time of your containers are very, light. Basically, it comes up in 2 seconds. If a lightweight application can come up in 2 seconds. We're going to quickly demo that also in next 10 minutes, of course. So that's one thing. And containers are having a very dynamic resource utilization also. Earlier, if you go to your virtual machines, right? Basically, if you go to virtual machines here, whenever we go to this one, right, you're having an operating system, you normally have a hypervisor, and then you normally set up your VM. Like whenever this VM is set up, the resources allocated for this particular VM is, it's kind of, it's kind of static. And so if your application running on this particular operating system needs more memory, then it definitely cannot extend. Means we can extend it, but we have to stop the system, and then you extend the memory, and then restart the machine, right? That's what it is going to be. So that means that whatever the memory or resources that are allocated to your particular virtual machine are static. So if you want to extend it, yes, you can extend it, but they cannot extend it dynamically. That is what is the biggest challenge with it. And whenever you want to create or clone this virtual machine into another machine, that becomes a very problem, and it's very resource contention. Everything will happen here. But when it comes to the containers, right, we have the same thing, but we don't have the virtualization anymore here. Like earlier, hypervisor or a virtual, VMware kind of stuff, they use the hardware level virtualization. But when it comes to the operating system here in the Docker, which is actually the OS level virtualization that will happen here. Means I know, team, we are talking about more terms here, technology terms. You will get it more when you go into the Docker deep dive sessions. That's what you can see. This is just a overview of Docker, right? So you just try to understand this way. And these containers have no resource limitation on them. Means that, these containers can take whatever the resources that are required from underlying hardware directly. We are not giving any resources to any of the container, so that, you're not limiting the resources. If that requires 1 GB, it takes 1 GB. And if it requires 10 GB, yes, it can take 10 GB, provided your hardware has that capacity available, right? Whatever it can be. So means that the containers are, again, very dynamic in nature, so that, they can extend their functionality or then resource utilization as and when needed. So that's what is the biggest advantages comes here with the containers again. So of course, this is biggest and virtual machines and containers are not same team, though they have the same thing like operating system and everything. The containers have very lightweight operating systems in it, and then they hold a very minimal operating system layer, so that, it is required to run your application. That is what is all there in the containers. So that's a big thing. That's the only thing you have it in your things. Okay, so this is a quick comparison about your containers here, containers versus virtual machines, how they help it. And, that's all the things. That's pretty much thing about, the Docker introduction here. And I'll stop here. If you have any questions, you can ask basically, or we can jump on to your practical things later. And there's a case study you can go to, read about this one, how Docker helped a lot of companies, improving their performance and all that stuff. So that's what it is, 10x increase in scalability and the Docker enterprise. This is just an article about a Visa company that they used a Docker to, in their organization. So that's one. So this is what it is, team. And then I'm stopping here. If you have any questions, please do let me know. Else I'll quickly show you the demo here quickly. So we need integration environment like dev system servers. Okay, I see a lot of questions here. Okay. Team, you can unmute and you can talk if you want. I'll give it here 5 minutes and we can do it. Okay. Okay. So team, let's jump onto the quick demo here, and then we can close this. I know people are having time here, so let's quickly jump. Yes, somebody wants to speak.
Hi, Naresh, this is Shobit. Naresh, I wanted to know like how we achieve logging functionality in the containerized environment, because containers are different, right? Container is working as an individual entity, and logging is something which is across the container. So how we achieve that?
Okay, so there is a concept called as Docker volumes in your Docker when you containerize your application, because you assume that whatever is writing the logs could be, inside the containers only, right? That's what is happening basically, because your application is running inside a container. Whatever the logs that are generated by your, containers, which will be inside the container only. But whenever you want to achieve, I hope you know that, right? You already use some kind of a NAS shares or something. You can attach something into your system, and then you can store all your log files from different systems into one single share, right? One single like pen drive. You store in a centralized location, right? Yes or no?
Yes, we do logging as a centralized service, but I wanted to know like how different containers communicate to that centralized logging service, and how we bring up that centralized service up. Do we deploy it in a separate container, or do we have some mechanisms to bring it in each container?
See, there is something, your container can be integrated. If you know about the Splunk as a logging tool, right? Every container, you can integrate with the Splunk so that, Splunk, they directly write everything into the Splunk. You don't need to worry about these things. You can mention some index name and everything, right? Every container writes the particular index and particular source type. So all the logs will be stored at your log. If you don't want to use the Splunk and then you want to use like an Azure only, yes, there is a concept called as Docker volumes. So that means that whatever the logs that will be written, they will be written directly into an Azure so that you can go to the share and you can read about the logs again. That's what is the solution that you can have it again with the Docker also. I hope that answers your question, right?
Okay.
Yes.
Yeah.
Did I confuse you anything or?
Yeah, probably we have to talk in detail to get it clarified. I will talk to you offline.
Sure. Definitely we can talk more offline. Okay. And team, I'm just going to show you a quick demo here about the Docker. We are not, this is something called as online. You have something called as labs.playwithdocker.com. Here you can create an account and then you get a machine to practice the Docker things, like whether to create a Docker image, to run the Docker image, to run the Docker containers and everything. So that's what we're going to do it. This is completely online. Everything, you don't need to worry about. I think if you have internet connection, that's good enough for you. And this is a session about 4 hours. After the 4 hour session, it will going to expire it, and your instances, right? Whenever you say add instance, you normally get a server here. Then with a Docker installed already by default. Okay, so with the Docker installed already here, that's what I can say it. I'm not showing you the Docker installation for now, but this is what it is. So likewise, right, if I ask you, just an example here, I'm telling you here. So if I give you a plain machine, and if I ask you to set up a Tomcat server, then how much time would you take it? How much time that would you take it normally? If I ask you to set up a Tomcat server, I give you a plain machine and I want you to set up a Tomcat server, how much time would you require? Quickly tell me. 5 minutes, 10 minutes, 1 minute. Team, do you want to answer? Okay, so team, we have a lot of containers, predefined Docker images, we can call it, available in the internet, something called as Docker Hub. Docker Hub is a place where you have predefined Docker images basically. So you can from there, you can start running your images directly. You don't need to really worry about this one. Okay, I'm just running a Tomcat container. Okay, so what exactly this is going to do is it is going to pull out a Docker image called Tomcat. Then it will run it as a container. That means that your Tomcat will be up and running in a matter of seconds. Okay, that is what it is going to do it for you. Okay, now I see that my Tomcat server is up and running. Okay, so guys, are you guys not seeing my screen? Oh, sorry. Guys, are you able to see my screen now? I'm really sorry. I hope I need to go back again. I'm really sorry for that. Okay, there is something called as playwithdocker.com, guys. This is like online sub where you can have it. You can create an account here, and then you can start getting an instance basically. Okay, instance is like you kind of get a server, and then you can start practicing about your Docker images and everything, Docker basic things. So you get an instance here. You can add an instance. That is kind of a server that you get it. A machine where the Docker is installed already. Okay, in which you normally have to just start practicing. I know I'm just showing you a demo here, but we will, whenever you go for the session, right, we can get more about how to install the Docker and everything. So the basic command here about is a Docker run -d and then -e. I mean, this is to run a container, guys. The command which I'm executing here is to run a container basically. That's what I'm trying to do it. So there is a Tomcat container that I'm trying to run it. Okay. So this container is nothing but, we have it, which will be up and running in a couple of seconds for you. I mean, as I said, like if I give you a plain machine and then ask you to set up a Tomcat, how much time that you would take? Maybe 5 minutes or 10 minutes, right? That is what is the ideal time that is required, because you need to download the software, extract it, set up it, and then you start the server and everything that you do it. That's what you do it, right? So that's what is the ideal time to set up a Tomcat server. But with the Docker image, right, you have in a matter of seconds, you can have your Tomcat server up and running basically. So it is up and running now. If you want to see this, let me show you. So if I just click on this one, now your Tomcat is up and running. Okay. So likewise, if I have to deploy your application, right, Hope you're able to see my screen also. So yeah, so this is what it is, right? If you can see that in a matter of seconds now, I was able to bring up my Tomcat server successfully because we have some predefined Docker images already available in the hub, which is nothing but we call it as a Docker hub. Okay, so I can quickly show that also, Docker hub, where we have n number of images, Docker images available, which can be used for your own purposes, or which are public actually. You can use them, you can do whatever you want with them, and you can create your own images of your application and everything. So that's what we all got to do it. This is kind of, if you can search here, whatever the technology that you want for a container team, you can search for it. You will get the image, a Docker image basically, which is nothing but a package which consists of entire runtime environment to run your applications. So that's what it is. The Tomcat is this one. So if you open this one now, so you can have the description about what the different versions it has, how it is built, and every information will be available here for you. I'm just showing you this one, but let's go back to the Docker playground here. Okay, so this is what is my server. If I have my server ready, right, then in a matter of seconds, I can spin up as many instances as I want also. Like I said, like if I want to create multiple Tomcat instances, normally how much time that I would take. Here at a single command, right, I can bring up as many containers as I want it, as you can see it, right? Right now, I have 4 different Tomcat instances up and ready for me in a matter of seconds, right? So this is, I'm just showing you a quick demo here, how it works. If you create your Docker, right, Docker instances, then that will leverage, or that will help you scale up your infrastructure. Not infrastructure, I can say, it can be application infrastructure, can be scaled so easily, and then can be maintained also very easily. Deployment can be done easily, rolling updates can be done, 24/7 applications can be maintained with your Docker, and everything becomes so easy with all predefined tasks and everything. So that's what is a quick thing, team. So whatever you want to run it, yes, Docker allows you to run it. How to create your Docker images, how to create your containers and everything is something we can do it on a full fledged session. But this is a quick demo. Like if I want to run again, like maybe HTTP container, right? Or HTTPD, or kind of, right? Let's say HTTPD is a web server, basically. Tomcat is an application server, and HTTPD is a web server, which I can do it. Yes, I can see that my web server is up and running now. If you can see this, web server is up and running in a matter of seconds here for us. The port number is 32772. Let's go back, right? And then 32772, it says. Yes, my web server is up and running in a matter of seconds for me. So this is, kind of Docker gives you flexibility. Once you create your image, right, it can be shipped anywhere, and then it can be run as you want it. How many times, how many instances you want to spin up out of it? Yes, you can do that also. Everything can be done so easily, right? That is what is the biggest advantages comes with the Docker. And nowadays in the market, everybody is trying to convert their applications into microservices. And then everybody is trying to create a containerization, or everybody is trying the containerization with this, because of the lot of advantages that comes with the Docker here. So this is what it is happening basically. And this is about team, and this is about the Docker containers and the Docker basically a quick containerization, why we need containerization and all. Quick thing. Right. So if you have any doubts, again, I'll leave the line for a couple of minutes, or we'll quickly discuss about this, upcoming course slides and questions. Yes, that's what I'm going to. Okay. So team, just to discuss about these things, right? This is about, upcoming courses in our DevLabs Alliance team. As a team, so we are bringing up these courses already. This launched 3D certified DevOps professional works. We have it. We have one thing scheduled in Hyderabad, one thing in Gurgaon on those dates. And we also have a specific course about the Docker with Kubernetes, weekend online webinars, as well as, we are taking the course also that is scheduled, as you see it, on the 15th of June to the 23rd of June, which will be only on the weekends team. That's what is very specific. So this is what it is. And of course, if you have any doubts, again, have any questions, sure, Chakravarti, we will do that. And any questions, team? and your team. So just to discuss about the market about the Docker right now. To be specific again, if you know Docker, yes, you are hired, right? That's what is a trend that is going on. People are looking for Docker experts or Docker experts in the market. We don't have a Docker skill in the market right now. If you can learn the Docker quickly and then you can put your resume, then you will get a job for sure in matter of a week or something. Everybody looking for these Docker experts or Docker skill, because everybody wants to try out these things all. Okay. Yeah, the question is one from Vinith here is, while creating images, dev needs to know each and every dependency. Yes, Vinith, they need to know all the dependencies, right? Because how they create the images is, they know about the application and then we know about the infrastructure, basically how we run it. So we both will work together and we'll create everything together, right? That's what is happening. So that's all. Do we have any case study available across net for this? Yes, Chakravarti, as I said, there is a case study that you can see it on my PPT. That is, if you go to docker.com customers, the top companies that you see, a couple of companies, one of them is Visa. So you can go through there and then you can read about this specifically, how Docker helped them, build other things, 10x increase in the scalability with the Docker enterprise and all. Yes, there is a lot of case studies available. If you go to Docker website, they have it very clear mentioned everything. Yes, somebody speaking. Okay. So team, thank you so much. I believe you enjoyed the session. Let us know. You can write to us if you have any questions, whatever it may be, and then we will try to give our best as always. So thank you so much. And then thank you, everybody. Thank you so much, team, and we'll see you next time.